Hello, welcome to my school. Alright, today we're going to cover a topic on geometry. Alright, we're going to cover more 2D shapes and 3D shapes. Alright, so in this topic, you'll be able to recognize standard 2D shapes and 3D shapes, and also to tell properties of these shapes. Alright, now the first thing we want to get into is we want to get into what are angles. Okay, so by now you should be familiar with what are angles, but let's go through them quickly. Right, now angles are basically a measurement that you have between two lines that are joined together. So for example, if I have a line here and another line that's crossing through it, all right, so this distance between this line to that line, this is what you call an angle. Okay, they're measured by degrees. So let's say, for example, this might be maybe 95 degrees with the thing there. Okay, so this is a thing that you will know throughout. We will be doing a lot of it. And few of the types of angles that we should be familiar with is one of them is the 90 degrees, right? This is called a right angle. So this, right, when a line is straight perpendicular to another line, it will be 90 degrees. Okay, this is called a right angle. Okay, so this is quite common. Alright, now if you look at the chart below, alright, if the lines, the measurement is below 90 degrees, we call it an acute angle. Alright, if it's exactly 90 degrees, you call it a right angle. If it's greater than 90 degrees or less than 180, alright, like this, has to be in between, slightly beyond 90 degrees, it's called an obtuse angle. Alright, these are the three common ones. Now beyond that, there are a few different ones. If the angle or the line is just straight, let's say for example, I have another line and another line connecting, right? The angle between here is basically a straight line. It will be 180 degrees. So basically 290 degrees added together, you get 180. Okay, an example would be, let me just quickly erase this to show an example. Alright, so for example, if I had a line and I crossed it, right, as you said, this is a 90 degrees and this would also be 90 degrees, right? So there are two different angles here. We have an angle from here to here and then an angle from there to there. But if you look at it, for this line and this line joined together, this whole thing is 180 degrees, because 90 plus 90 is 180. So a straight line is exactly 180 degrees. A reflex angle, which is basically an angle where it's 90 degrees added. So for example, I'm going to do in red, from this point going all the way down to here, right? So it's 90 plus 90 plus another 90 here. So reflex angle, greater than 180, less than 360, so it should be within that range. All right, doesn't have to be exactly 270 degrees. And a full angle where you go full circle is a full 360 degrees, right? So this is just some information you should know. Okay, now let's get back to 2D shapes. Okay, first we went through acute, right angle and obtuse angle. Now why that's important is because in the types of triangles we've known equilateral, isosceles and scalene. Then we have another tree that is based on angles. Alright, so we have an acute angle. Maybe for example I draw one like that. Right, all the angles inside the acute angle, so meaning we have three angles, each of these angle will be less than 90 degrees. All three. So if you read here, has three angles less than 90 degrees. Now right angle would have an angle, just one single angle that is 90 degrees. So that is called a right angle. And lastly, an obtuse triangle would have one angle that is an obtuse. Okay, so let's say, like for example, like this probably is about, maybe let's give it 100 degrees, and the other two will be, might be 40 degrees, can be 40 degrees as well. Okay, these two are acute. So if you read here, has one angle that is more than 90 degrees. Okay, so these are three new types of triangle you'll be learning now. All right, now let's get into 3D shapes. Okay, now in previously mentioned, maybe the 3D. The D stands for dimensions. So in 3D shapes, an object would have 3 dimensions. So for example, if I were to draw a cube, right, typically it starts with a square. From here to here we have, maybe let's say it's a length, and here to here we have height, right? Okay, we're just gonna write height. Okay, that's why this is 2D, because there's 2 dimensions. Now if we have 3D, right, it's the same thing, but we're adding a 3rd dimension, a 3rd measurement, so to say. Let's just draw like that. Okay, so again we have the length, here we have the height, but the 3rd dimension here we have depth or width, can be called. Alright, so few different types of 3D shapes we have. Alright, most of you should know what are cubes, cube and cuboid. Cube is basically a 3D shape that is squares everywhere, so it has 6 faces, and yeah, 6 faces, all square. Now cuboid is a similar thing as cube, except it's rectangular faced. So you can see that if you look in the image here, this is rectangle, this is another shape, might be another rectangle. Okay, so that's a cuboid. Okay, as for the next few, you have a sphere and ellipsoid, which are not edged. It does not really have sharp edges, it's circular, and I have put an image here to show. Right, so essentially this is a sphere, our earth is a sphere, right, a ball is a sphere. Okay, so it's just nice and rounded. And ellipsoid is sort of like an ellipse, that's a shape, or oval, so something like that in 3D form. Alright, a lot of candies are shaped this way as well. Okay, and we have cylinder and also cone. Alright, now these 4 are rounded objects, so they are slightly different. So a cylinder basically has a circular base, circular top, and then a circular base. Alright, this is circular base, and then is connected together by a rounded surface. Okay, that is a cylinder. As for cone, we have a circular base and is connected together by a rounded surface, but it is met at a sharp point at the end. So this is a cone. This is a cylinder. Okay. Yeah. Alright, then we have the more sharp 3D objects. So in this case, for example, we have the prisms, we have the pyramids. Right, now prisms, by definition, what it means is on the front and the back of it will be a polygon. So for example, if I were to take a triangle, the front is a triangle, the back is also a triangle, met by more rectangles. So you can see it is surrounded by rectangles. I'm gonna mark it in black. There's a rectangle here, there's a rectangle on this side, and then there's a rectangle on the bottom. So there are polygons from the front and the back met by rectangles. So what we would call this is, we would call this a triangular prism. Okay, now similarly we could have any other shape. We could have hexagonal. So I'm going to just draw a pentagonal one. So for example, something like that. Oops, not a really good drawing. Okay, just going to try my best. Right, something like that. Alright, this would be a pentagonal prism. So prism on its own, by definition, you should know that the front and the back would be one of the polygons. Could be square, could be triangle, could be a hexagon, could be anything, met by rectangular sides. As for pyramids, they could be any base. So for example, I'm going to use our basic pyramid of having a maybe square base met at the point. Okay, so there will be square base, so you can see this is square based, and there on the sides there are triangles met at a point on top. So this is what you would call a pyramid. Alright, a base with triangles surrounding it met at the top as a point. Okay, so you can see here there are different types. There's triangular based, there's square based, there's hexagonal based. So if you look closely, this is a triangle, the base of it. Here is a square, here is a hexagon. Okay, some of the more important information is stated here, so you can always use this as reference throughout the video. And lastly, we're going to go into the properties of these 3D objects. So I've left a GIF here, so if you ever want to see a visualization of it, you could just refer here, but I'm going to do my own drawing as well. Alright, so I'm going to start off with a square. Alright, I'm going to start off with a square. Sorry, a cube. That's what I meant. Okay, or a cuboid. Let's say something like that. Okay. So over here, this is not really greatest drawing. Okay, we have a few different properties we need to look at. We have faces. Alright, then we have what we call, instead of corners, we call them vertices. Right, this is plural, but it's actually a vertex. Okay, for one. And lastly, edges or sides. Okay, so these properties, basically every shape has this. So faces means the front or the sides of the objects that are you can see or you can touch. So for example, this is one face. Alright, and the back here there's another one. 1, 2, sorry, 3. The bottom there's 1, 4, 5, 6. So I would say in a cube and a cuboid we would have 6 faces. Alright. As for vertices, they are the sharp points in the object. So for example, these are the sharp points, the corners. 1, 2, 3, 4, 5, 6, 7, 8. So you should have 8. Right, and lastly for the edges is basically the sides itself. So it's like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you count them, you will get 12 edges. So every shape has a different these 3 properties differently. Alright, so a pyramid would have different ones. So let's say for example I draw a pyramid, a quick one. Alright, so in the pyramid we have I'm just going to use green again. 1, the base, 1, 2, 3, 4, the back here 5, and sorry, 1, 2, 3, 4, 5. We have total of 5 faces. As for vertices, we would have 1, 2, 3, 4, and 5. 5 vertices. And the edges. Alright, as for the edges, we'll have, let's count the square first. 1, 2, 3, 4, 5, 6, 7, 8. We have 8.